Hello dear students, I am Ajay Karmarkar. Before starting further, I would like to say something. Please watch video completely, sit with copy pen. If you find somewhere important, pause the video, note it and proceed further. Although you have facing any problem or difficulties, then please write in comment box. I will definitely solve your problem. And along with, please like, share and subscribe my channel that can reach more and more students. Thank you. Here is the question. A simple pendulum is made of a string of length small l and a bob of mass small m. Is released from a small angle theta naught. It strikes a block of mass capital M kept on a horizontal surface at its lowest point of oscillations. Elastically, it bounces back and goes up to an angle theta 1. Then capital M is given by. Here we have given four options. First option A, small m into bracket theta naught plus theta 1 upon theta naught minus theta 1. Option B, m by 2 into bracket theta naught minus theta 1 upon theta naught plus theta 1. Option C, small m into bracket theta naught minus theta 1 upon theta naught plus theta 1. And option D, m by 2 into bracket theta naught plus theta 1 upon theta naught minus theta 1. We are using two concepts. First, laws of conservation of momentum, and second, definition of restitution. And because we have given the collision is elastic, it means energy is conserved. This concept you should have to be remembered. Initially, it's make the angle theta naught and total length is L, and here the block is kept, and after striking its velocity become v1 and its velocity become v2. So therefore initially we have to take theta naught, then cos theta naught. It is the base. So here, what is the base here from O to A? That is L minus H, because this level from the ground and to the up to the height is H. So therefore L minus H, and hypotenuse is L, then L cos theta naught equal to L minus H. Then here H is equal to L minus L cos theta naught. Here L get common, 1 minus cos theta naught. So we get here H. Now the collision is perfect elastic. It means their potential energy. What is potential energy? Up to height h, mgh, and half mv square are equal. M get cancel out, and substitute the value of this h is putting here L 1 minus cos theta naught and equal and 2 here v square. Then v can be written as root 2gl 1 minus cos theta naught. So we get here velocity v equal to root 2gl 1 minus cos theta 1. Now after striking this bob to this block and goes to back, bouncing back, then its velocity become v1. Same formula we have using here, 2gl, only angle is changed, then 1 minus cos theta 1. From the definition of restitution, you know that E equal to after collision and before the collision, the velocity after the collision and velocity before the collision. Here we have using after the collision, this block become v2 and this is v1, but that is an opposite side. So therefore we have using here negative sign. And v means before collision its velocity is v, and the block is that time it is in rest. So therefore we have to put here 0. And perfect elastic, the value is become 1. So here 1 equal to v2 minus minus plus v1 upon v. Then v equal to v2 plus v1, then v minus v1 equal to v2, or it can be written as v2 equal to v minus v1. Now substitute this value What is the value of V? Root 2GL 1 minus cos theta naught. 2GL get common, and here again, because 2GL, here 2GL, so we have get common, and 1 minus cos theta 1. So we have get V2. It is equation number 4. Now from the laws of conservation of momentum, mv before collision, mv after collision, mv2 minus mv1. Here we have using minus because the bob goes to this direction, the block goes to right side and bob goes towards to this side. So therefore we are using here the sign is opposite. Okay. So here mv equal to capital M v2 minus mv1. Here mv plus mv1 equal to mv2, or it can be written as mv2 equal to m get common v plus v1. Now again substitute this value. What is the v? Root 2gl into bracket 1 minus cos theta naught plus, here 2gl we have got already common because this term comes in both v and v1 also. So here 1 minus cos theta 1. This is equation number 5. So now lastly we have divided 5th equation by 4th. So mv2, and this is v2 m 2gl root 1 minus cos theta naught plus 1 minus cos theta 1 upon, what is the terms here? 2gl root 1 minus cos theta naught minus 1 minus cos theta 1. So here 2gl cancel out, v2 cancel out, then m by small m equal to root 1 minus cos theta naught plus 1 minus cos theta 1 upon 1 minus cos theta naught minus 1 minus cos theta 1. As you know that by using trigonometry, cos theta can be written as 1 minus 2 sine square theta by 2. So 2 sine square theta by 2 can be written as 1 minus cos theta. So here we have using this property capital M upon small m. Here you can see that root 2 comes in both the terms, so therefore we have get already initially we have get the common. Here sine square theta by 2 plus sine theta naught, sine square theta 1 by 2 upon sine square theta naught by 2 minus sine square theta 1 by 2. Root 2 get cancel out, capital M by small m. Now root and square cancel out, so therefore remaining terms sine theta naught by 2 plus sine theta 1 by 2 sine theta naught by 2 minus sine theta 1 by 2. Here you are well known that in practically this angle of bob is very small, that time sine theta approximately theta. So we have put here theta naught by 2 plus theta 1 by 2 upon theta naught by 2 minus theta 1 by 2. Then it can be written as theta naught plus theta 1 upon theta naught minus theta 1. This m transposing to the right side, and this will be our answer. I hope so you understand this question, and so therefore this is our right answer. Thank you for dear students staying till the ends of this video, and I know that very well you are working very hard, and if I will be a part of your success journey, that it will be my pleasure. But when more and more students will join with your success journey, then it will be very great things. Thank you once again. Take care.